This is the first one, and solution for the first one. Carrier concentration is 33.49 Newton per 18 per meter cube. And coming to the second one, we need to find out at what temperature the Fermi level is shifted by 15%. So from the middle of the forbidden energy gap, that one also we solved yesterday. That at 1729 Kelvin, the Fermi level is shifted 15% from the middle of the forbidden energy band. And for silicon, energy gap is given and EF at temperature. Find EF, Fermi energy level at the temperature 300 Kelvin. If ME star and MP star is given, so use the formula EF equals to EC plus EV by 2 plus 3 by 4 KT log MS star by ME star. We solve the problem. That is EF equals 0.576 electron volts. And calculate the Hall voltage developed across the width of the slab. So use the formula RH into B into I divided by T. Now if you try to find out the Hall voltage developed across the material. So RH is not given directly in the problem. Use the formula RH equals to 1 by N into E because of N is given. The charge density is given. Using the formula RH equals to 1 by N into E. First find out the RH. RL substitute in the same formula. Substitute RH equals to 1 by N into E. Then solve the problem. We already solved yesterday. We get 1.431 micro or 10 power minus 6 volts. 1.431 into. So coming to the fifth one. Tell me the answer for fifth one, Amma. Tell me the answer for fifth one. I'm given as assignment, I think. Right? I explained the formula also. So what is the answer for the fifth one?
0.47 ohms, sir.
0.47. So we will see 0.471 ohm meter. Right?
Yes, sir. Yes,
so
sir.
Resistivity. First we are finding the conductivity using the formula N into E into mu. But your intrinsic carrier concentration is given. We are taking into the consideration of mobility of electron as well as mobility of hole. So here I am given mu E and mu E, but this is 1 second. So this is mu P. Mu E plus mu P. So using this formula, first find out the conductivity. After that, using the formula resistivity equal to 1 by conductivity, find out the resistivity. That is 0.471 ohm meter. How many have got that answer, Amma? Please raise the hand. If you got the answer, please raise the hands, Amma. Only one student raising the hand, Amma. Only two. Two only. Only two. Good. Very good. Very good improvement. I appreciate everyone. Three only. You are thinking. Still you are thinking. Okay. That is your wish. So calculate the intrinsic charge carrier concentration for germanium at 27 degrees Celsius. So intrinsic carrier concentration, anybody get the answer, Amma? I'll get the answer. Please reply. Keep your answer in the chat box, Amma. If you get the answer, please keep your answer in the chat box. Or else unmute and tell. No one. Good, very good. Very simple one. Already we done a similar problem. So this is the equation for intrinsic carrier concentration 2 pi n naught kT by h square whole power 3 by 2 and exponential of minus h by 2k. So use the formula, try to find out 33.49. I think it is the wrong answer. 33.49. All of you try to calculate yourself, Amma. Okay. So formula will be 2 pi m naught kT by h square whole power 3 by 2 exponential of minus Eg by 2 kt. Because mass of the electron and mass of the hole intrinsic carrier concentration we are taken equal. 9.1 into rest mass of the electron. 9.1 into 10 power minus 31. This is a solution. If you not done, please note down or else take a screenshot. After the class, I'll have to try to note down in your notebooks, physics notebooks. Because of these problems are very, very important for your examination purpose as well as the CAE and semester end examination also. Try to concentrate on the problems. 5 into 7, 35 marks you are getting in problems. So coming to the sixth one, anybody solve the seventh one? The intrinsic carrier density is 1.5 into 10 power 16 per meter cube. The mobility of electron and holes are given 0.13 and 0.05. Similar to the fifth one. So your given data is, what is the given data? Carrier concentration is given. Carrier concentration is given. So n equals to, sorry. So n equals to 1.5 into 10 power 16 per meter cube, electrons per meter cube. Mobility of electron mu e equals to 0.13. At least now solve, all of you try to solve now at least 0.05 mobility of hole. We need to find out conductivity rho. So rho equals to, in terms of these quantities, we have a formula Ni into E into mu E plus mu H. In the previous problem, resistivity is we are finding the resistivity, but no need to find out the resistivity here. Only conductivity we have to find out. Using this formula, try to find out the conductivity. So Na equals to 1.5 into. Try to solve and tell me the answer from all of you. Into charge of the electron is 1.6 into 10 power minus 19.
Sir, 4.32 into 10 to the power of minus 4.
4.32
into 10 to the power of minus 4.
10 to the power of
Minus 4. Yes,
units
sir.
ఏంటి? What are the units for conductivity?
Ohms.
Ohms. Ohms. Okay. So 1.6 into 10 power minus 19 and 0.13 plus 0.05 plus 0.05. Then it will be very easy to solve. So rule number 63, I think, is solved the problem. We get 4.32 into 10 power minus 4 ohms. Ohm meter. So all of you, are you get that answer, Amma? Please give reply in the chat box, Amma. Ideally, try to solve. So given data, I wrote there and formula also given. Try to substitute in the formula and get the answer. It takes 1 minute, below 1 minute. But no one responding. Only 2 students. 31 yes sir, 49 yes sir. What is? I am asked to post your answer. Don't tell yes or no. So this is the 7th one. And coming to the 8th one. So 4.32 into 10 power minus 4 ohm meter. So for the 8th one, for a semiconductor, the Hall coefficient is minus 6.85 into 10 power minus 5 meter cube per coulomb. And the electrical conductivity is 250 ohm meter. And calculate the coulomb density and mobility of charge carriers. Mobility of charge carriers, we are going to find out. Hall coefficient is given. So coulomb density nothing but n, using the formula RH equals to 1 by n into E. Substitute, find out the n first of all. RH equals to 1 by n into E. We have a formula. So n is the charge density. So from that, n equal to 1 by RH into E while substituting RH, don't consider that minus symbol because of this minus symbol indicates whether the material is P type or N type. Only it indicates that one number. Don't take minus symbol while substituting the RH in the formula. Okay, so finding the Coulomb density, mobility of charge carriers. So what is the formula to find out the mobility of charge carriers? Rho equals to conductivity, rho equals to N into E into mu na. Okay, conductivity, electrical conductivity is given rho equals to 250 and number of charge density or Coulomb density we are getting from this formula. So E is charge of the electron and we can find out the mu by substituting conductivity, Coulomb density or number of electrons and charge of the electrons. So tell me the answer, Sama, for this one and for this one also. Mu equals to what is the formula here? Rho by N into E. Rho by N into E or substitute direct RH 1 by N into E. So rho into RH also gives the 1 by N into E nothing but RH only na. So while substituting RH equals to 1 by N into E equals to RH, you will get the answer. Mu equals to something. So tell me the answer, Sama. Tell me the answers. No one responds. Great people you are. Conductivity equals to 4.32 into 10 power minus 4 sigma. I'm going to give 1 minute of time to everyone. Please solve the problem and post your answer in the chat box. Who responded? That those people only get the attendance. Otherwise, you lose the attendance. You know about me. I'm not going to give attendance to everyone. ఎవరైతే రెస్పాండ్ అవుతారో వాళ్ళకే అటెండెన్స్ ఇస్తారు. ఊరికే ఐడియల్గా అవసరం లేదు కదా క్లాస్ అటెండ్ అవ్వడం. This attending is for fun. No, na. So try to solve the problem. I given the formulas there clearly. Try to solve and tell me the answer. Keep text message in the chat box. Those posted your answers in the chat box, they that students only get the attendance. Otherwise, I give full absentees. If no one responded, I'm giving 0 attendance to this class. No one. వినిపిస్తుందా అండి మీకు? Is I audible? $56 or 49? Is I audible, Amma?
Yes, sir.
Then why are you sitting ideal? I want answer from everyone. Not only one or two. Any question 29 given the reply 9.1 into 10 power 22 electrons per meter cube. So after that 17.125 into 10 power minus 3 is the mobility. So we'll check. We'll check 29. So 49 also get the same answer for the Coulomb density or number of electrons or charge density. So what about that mobility 49? So it takes only 2 minutes of time to solve. If you have a calculator with you, so it takes only 1 minute of time to solve. But no one trying. Rule number 8, 49. $22. If mute yourself, 22. Still getting some noise from your side, 22. రిమూవ్ చేసేస్తానమ్మా నేను. I'm going to remove. Right. Okay, see the answer, Amma. So for semiconductor, the Hall coefficient is minus 6.85 into 10 power minus 19 and conductivity 250 ohm meter. Number of electrons or density of electrons we need to find out using the formula RH equals 1 by n into E. So when we solve, we get 9.1 into 10 power 22 electrons or atoms per meter cube. And using the conductivity equation, rho equals to n into E into mu, find out the mobility. Mobility equals to rho into rho divided by 1 into E, or else rho into RH also you can take. So you are getting 17.12 into 10 power minus 3. Note on all of you. Now coming to the ninth one, next one. So RH is RH, nothing but Hall coefficient is given like 3.66 into 10 power minus 4. Its resistivity also given. So find out the mobility. At least all of you try to solve this problem. At least, because of I think this is the last one. Try to solve the problem. I'm going to give 2 minutes of time. So write down the first given data. What is the given data? RH equals to 3.66 into 10 power minus 4 and resistivity rho equal to 8.93 into 10 power minus 3. We need to find out mobility. Right? What is the formula to find out the mobility? So we have a formula for conductivity, rho equals to n into E into mu. So from that mu equal to rho divided by n into E, that equals to rho into RH. Right? So conductivity, sorry. So conductivity equals to 1 by resistivity. So I'm taking 1 by resistivity into RH. So use this formula. I'll have to try to find out the mobility. So rho is 8.93. Sorry, resistivity is 8.93 into 10 power minus 3 and RH is 3.66 into 10 power minus 4. Zero 49 posted the answer and 33 also 31 sorry. Both are posted the same answer 0.041. So 58 also. 60. Don't forget to write the units, Amma. Because if you forget to write the units, you lose 1 mark out of 7. If the same problem is given in your semester examination, you lose 1 mark for forgetting your units to write the units. 64, 56, rule number 4, rule number 60. Other posted are the same answers. Okay, good. So some students are trying to get the answer. Try to solve the trying means they are trying to solve the problem. Okay. At least some students are listening classes. It's happy for me. See the answers. So 0.041 meters square, old inverse and second inverse. No need to use these all the formulas directly. Take this formula. Mu equals to 1 by resistivity into RH. Get the answer directly. Sixty-four 23, number 9. So these are numericals from the module 2, only few we discussed. 41 also posted the answer 0.04. Okay. So these are the problems or numericals from the module 2. So once again I'm going to repeat the PPTs. So first one is for intrinsic semiconductor with band gap of Eg, calculate the intrinsic carrier concentration at T temperature. So Me star MP star equals to rest mass of the electron. So we know the formula. So I try to remember the formulas. What we are discussing in the module 2. Try to remember the formulas. Then it is easy to solve the problem. When the problem is given, first of all, write on the given data. So related to the given data, identify the formula to find out the unknown one. Yeah, that is the procedure to solve the every problem. So 33.49 into 10 power 8. Once recheck the answer, for the because of for the next problem also, for the similar problem, we are getting same answer. So coming to the second one, at what temperature would the Fermi level EF is shifted 15%? So we know that Fermi energy level at particular temperature, but at 0 Kelvin EF equals to EC plus 0.6 electron volts. So after that, what we are taking? So EF equation we are going to substitute EC plus EV by 2. So after that T equals 0 Kelvin. So we are taking the 15% shift. So 15% nothing but 0.18. So added to 0.68. So if you add it, so 0.78 we are getting. So at what particular temperature, that's why we are taking in terms of Fermi energy level equation in terms of temperature also. 3 kT by 4 log 5. So now this is not log 5, try to substitute Ma star by Me star. So temperature you are getting, I think 1729 Kelvin. So for the third one, at least now take the screenshot of the solution sum, each and every one. I think 55 students are attending the classes. Attend the class attending 55 students. So all of you try to take a screenshot of every solution. Silicon Eg is 1.12 electron volts. Find EF at 300 Kelvin if Me star and MP star is given separately. Okay. After that, calculate the hall voltage developed across the material, across the width of this slab of a metallic slab carrying a current 30 amperes subjected to a magnetic field of 1.75 Tesla. The magnetic field is perpendicular to the plane of the slab to the current also. So we know that is the Hall effect. Both all the three components are mutually perpendicular to each other. Current, magnetic field, and electric field. The thickness of the slab is 0.35 centimeters. The concentration of free electrons in the metal is 6.55 into 10 power 28 electrons per meter. So using the data, try to find out the VH. So formula will be RH into B into capital I divided by D. So RH equals to I am taken 1 by n into E. Yesterday these problems are we covered. We covered these problems in the previous class. In today's class, we are covered at 6th, 7th, 8th, 5th one also, 5th, 6th, 7th, 8th, 9th also. This is the 5th one solution. Try to take a screenshot. And this is the 6th one, solution of 6th one. All of you try to take screenshot. So once check the answer, whether it is correct or not, once all of you check the answer. Because of I'm having little bit doubt about that answer. Anybody, if you get the correct one, please respond. Anybody, if you solve, if you get the same thing, or else if you get another answer, please post in the chat box. Coming to the 7th one. So this is the 7th one.
Sir,
Screenshot. Tell me.
for first one, it is coming 33.19, sir.
Okay. Then what answer we are getting? I wrote what answer there?
33.49, it is there, sir, for first
Okay,
one.
33 point something is okay, na? If you take an instead of charge of the electron, if you take 1.6, they are taken 1.609 into 10 power minus 19. So like that, you are getting that small fraction difference, no problem.
Yes, sir.
If you get 33 point something, then it will be okay.
Okay, sir.
For the 6th one, same answer you get. Are you getting the same thing? Try to find out, try to solve. Okay. So 7th one is over, and coming to the 8th one. So take a screenshot of 8th one also. And coming to the last one, 9th one. All coefficient is given, resistivity is also given, find out the mobility. So here they followed the long procedure. I'll use the same formula, whatever we discussed in the class, mu equals to 1 by rho into r by h. So try to solve the problem using this formula, and then it will be very easy. One second. Use this formula, try to find out. So then it will be very easy. You are getting the same answer. If you follow that process also, you are getting the same thing. 0.041. Is you're having any doubts regarding the numericals? No one having doubts? I'm going to stop sharing. So please raise the hand. So if it is clear to everyone, please raise the hand. The problems are clear to everyone, please raise the hand fast. Only 29, 49, 39, 4, 2, 16, 28, 31. Only 20 students are raising their eyes. 24, 26, 27, 30, 29, 30. Half of the students are raising their hands. Okay, good. No problem. Okay. So coming to the rule numbers, I call the rule numbers again that who are not uploaded the worksheets in the login. Rule number 7, 12, 14, 17, 22, 24, 25, 27, 41, 42, 45, 59, 61. In that student 61, I think, taken the permission, and 14 also. Now he is telling he is having some login issue. So we'll see.
No, sir, not clear, sir.
14 or 17 ఎవరు చెప్పారు కదమ్మా.
Sir, 17
14
names
clear, sir.
చెప్పాను సార్ మీకు
Sir, clear,
last
sir.
చెప్పట్లేదని.
17.
17.
Okay, we will
Sir,
see
14.
after
Sir,
the after
14.
the class. 14 also not uploaded, Amma.
Clear, sir. Problem is clear.
Okay, 17 not uploaded, Amma.
సార్ అదే సార్ నీకు చెప్పాను సార్ మీకు చెప్పాను నేను.
అవునవును నిన్న ఫోన్ చేసావు కదా బట్
అవును సార్.
17 and 61 both are taking the permission. Only 2 students taken the permission. Okay, I will consider 17 and 61. We will see. Okay, the remaining are I am not going to consider their worksheets. So for the fifth one also some students having pending valuation is pending lo undi.
Sir, roll
Amma.
number 43. అదే 5th week evaluation, sir.
చేస్తా.
పెట్టాను.
నిన్న మెసేజ్ చేశారు కదమ్మా చేస్తా.
అవును సార్. ఓకే సార్.
Okay, okay. Thank you. So it's only 1:20. More 10 minutes we have. So I recall the topics from the module 2. So what we discussed in the module 2 up to now. So only the topics remain. Only the topics we covered from the module 2 are first. We discussed about the band theory of solids. What is the band theory? And the things we discussed at the starting of the class. After that, we discussed about our topic is started from the Bloch's theorem. Bloch's theorem. What Bloch's theorem states? The energy, the potential energy of the particle is not a constant. It will be varies according to the periodicity. So if the periodic arrangement of atoms, if you are taking into the consideration, the potential energy of the particle is varies according to the periodicity. If it is a periodicity near to the atom region or near to the positive ion set, particle having some kind of potential in between the two positive ion sets, means this in this region some kind of potential energy having that particle, and it means two kind of potential energies having the particle. So with the two, using this Bloch's theorem, chronic penny model, both are designed a model. In that model, we can say allowed energy bands are separated with the forbidden energy regions. Chronic penny. Next topic. In that model, we are finding allowed energy bands are separated with the forbidden energy gap. So we get one solution in the chronic penny model by solving the two differential equation in the two regions. This is the region 1 and the region 2. With the potential energy variation, we constructed two types of regions. One is the minimum potential energy region, here minimum, and in between the two positive ion sets, that is the maximum potential energy region. So by solving the two differential equation in the two different regions, so you get final solution like P into sin alpha A by alpha A plus cos alpha A equals to cos K into A. So when we draw the plot between P and this total term, okay, so we are getting allowed energy bands are separated with the forbidden energy region. This is a graph for that. So this is restricted between the particular values +1 to -1. Because of this total term equals to, we are getting cos K into A. So cos values are restricted between only +1 to +or-1. So this wave also or energy also restricted between the particular values like +1 and -1. +1 and -1. Sorry, +1. This is -1. So alpha A we are taking the x-axis. This total term we are taking the y-axis. So allowed energy bands are, these are the allowed energy bands are separated with the forbidden energy region. So energy is distributed from this point to this point only. Like this, allowed energy bands or electrons are distributed up to this region. Okay. So means these are the allowed energy bands. Allowed energy bands are separated with the forbidden energy regions, and including that we are discussing the conclusions also. What will happen with increasing of alpha A, and what will happen when alpha tends to 0, and what will happen when alpha tends to or P tends to 0 or P tends to infinity. These are the three conclusions from the chronic penny model. Already we discussed about that. So after the classification of solids into conductor, origin of energy band, including that how they are classified into conductors, semiconductors, and insulators. Origin of energy bands, including that we discussed about classification of solids. Classification of solids. These are the topics under band theory. Classification of solids. So these are the topics under band theory. After that, we have another topic in the module, same module, module 2, semiconductors. In the semiconductors, we are discussing about the intrinsic and extrinsic. Intrinsic and extrinsic. Intrinsic semiconductors are pure form and extrinsic semiconductors are impure. So semiconductors having the both properties in between conductors and insulators. Now, when they are in the pure form, they are acting as insulators at low temperatures. In the process of finding the conductivity, we are going to add the dopants. When we added the dopants to the pure form, the semiconductors are called as extrinsic. So two types of dopants we are adding. One is trivalent impurities and the second thing is pentavalent impurities. If you added trivalent impurities, the semiconductor will be P type and pentavalent is N type semiconductor. So in that we are finding the intrinsic carrier concentration. Intrinsic carrier concentration. Intrinsic carrier Ni. Ni after that Fermi energy level EF also. EF equals to EC plus EV by 2 plus KT by 4 log something we are getting is at low temperatures. So after discussing about the intrinsic semiconductor, in the extrinsic semiconductor, we are finding N-type carrier concentration as well as P-type carrier concentration. So after that, we discussed about the Hall effect. The last topic is Hall effect in the module 2. What is Hall effect? When a piece of material placed in a transverse magnetic field. This is a piece of material. When it is placed in a transverse magnetic field, what will happen? Perpendicular to both the current and the magnetic field, what will happen? Electric field will be generated. That is called as a Hall electric field. Due to that developed electric field, what will happen? Potential difference is creating between the two ends. So voltage developed across the material, that voltage we are taking as Hall voltage VH. So using these three quantities B, EH and VH, and one more thing we are taking RH, Hall coefficient, we are finding some relations in the Hall effect, and we discussed, including that we discussed some and applications about the Hall effect. Can any one of you tell me the applications of Hall effect? Any one of you unmute and tell me the applications of Hall effect. No one really. Good. No one ready, Emma?
Sir, for determination of type of given semiconductor.
How can you determine the type of semiconductor?
If RH is negative, it is N type. If RH is positive, it is P type.
Very good. So if you know the RH, what we finding? What we are going to find out?
Carrier concentration.
Carrier concentration. Once we know the RH, using the formula RH equals 1 by N into E, we are going to find out the charge
Carrier
density.
concentration.
Charge density of the semiconductor. Right, Inka? Once we know the N and RH, we can find out the mobility.
Mobility also. Yes.
Using the conductivity equation, rho equals to N into E into mu, we are going to find out the mobility. So these are some applications. Okay, all of you try to remember. All are interlinked with each other. So these are the topics we are covered from the module 2. Only the topic is remaining from the module 2 is only little small topic, that is variation of Fermi energy level for intrinsic and extrinsic semiconductors, N type and P type semiconductors. And then in the next class, we are going to cover the topic. After that, we started the module 2. Module 3. Right, clear to everyone?
Sir,
Amma.
sixth question answer, it is coming 1.439 into 10 to the power of 11 meter cube.
Okay, keep the same thing, 1.4 into 10 power 11.
Yes,
But the
sir.
carrier concentration you are getting about 10 power 20. Once again recheck. So I will also check
Yes,
the
sir.
answer.